Hi, I'm Alicia Brittany, and I'll be talking about the 7 important concepts of chemistry. The 7 important concepts is radiation, electron, waves, and energy equation, quad, quad numbers, electron configuration, Leo dot structure, the SVEPR theory, and and ionic bonds. Now, for the electromagnetic radiation is a wave of travel energy. So that means and X-rays, visual light like rainbow, obviously a light in the room, or a microwave. Microwave are the lowest because they don't use as much energy as light does, because light takes up a lot of energy with everything that's going on with that. Then you have X-rays, which take up a lot of energy because it has to focus on certain stuff like a brain tumor or broken bones or finding blood clots and stuff like that. So you have to know that. And I have examples right here of how the waves look. Microwave's the first one because it's the lowest one, and then it goes up. Now the next topic is going to be talking about the equation, which is the wavelength and frequency. Those are similar to beach waves. The radiation of them are similar to beach waves, and they are called crease or thumps. Like thumps are a speed bump, and then because they're lower and you have to go slower and stuff like that. Now the crease are smaller, higher, and faster. And now here are symbols that you will need to remember in the meaning of them, which is an upside down V, wavelength, a regular V, frequency, and then right here a C means speed of light, which has an equation that you will divide against the equation of one of these to find the main overall frequency or light width of a wave. Now back here, because frequency is the number of times the crescent waves passes through it by a second. So now here are the equations and how you would solve it. These are the main two equations you would use when you're dividing by the light speed, and this is how you find your answer for either one, either speed or frequency or length. So down here, you're going to take it and you're going to separate them and divide them. Now, the first one, you're most likely going to get a decimal, and that's okay. But you cannot leave it with the 0. You have to move this over, so do not have a 0. So do not have a 0 right there. It cannot be with the 0, because then the equation is going to be wrong. Once you do that, you're going to round it up, which is going to give you 0.0, which is then going to be your equation and your answer to the problem. And then here are 2 more equations that I did as far as solving for them. Now the next topic is going to be the quantum numbers, which is NL, ML, MS. And the quantum number describes the electrons, which is in the energy level N, the shape L, the orientation ML, and then the spin, which is MS. It determines the placement in the chemical property. And that's how you'll find that, and that's what you'll find on your charts, which will be these little numbers right around here, and that will show you the level of it or not. There's a chart that shows what is what. 1 is the first one because it's the lowest one. You have to know that it's the lowest one, and the order is right here. S is the lowest one, so it does the least effect, and the highest is F. Back here is an example, more examples of the quantum numbers, where what goes what and which is what. Now, one thing about these two is if this is negative, this is negative. So it's gonna be, so this is a positive, so it's gonna be plus a half. If this is a negative, it's gonna be minus a half. Positive plus a half. And that's how you'll do that for that. Always remember that. Now, topic 4 talks about the electron configuration, which you will need this, the atomic number, to solve with the electric configuration, because the S in the atomic number is the type of orbit you're solving for, plus the number of electron, which is in the corner of your thing. That's how you'll get that. You have to look at your chart for those. And 1S is written first because it's the lowest, and that's on the chart that I showed down here. Now with that one, right here is a chart of how you will get your electron configuration in order. That's the element, that's the number. The number is the arrow in the box. This right here is is what it stands for. So because it's 1, it's 1. Now right here is 2. So this is how you do that. The arrow and diagram shows you what you're gonna put right here to 1S1, 1S2. Very easy. I mean, it should be easy. And now here shows all of that too, and these are different elements. Now every one of these will be different based off the elements. The elements in the atomic number, and that's how you would add. You would split them right here. You would split them each right here. Some ain't gonna have all of this because they only have 1. That's fine. That's why you would put this, that, 1. This right here, they have more than 4. So you'll have to split them in halves like this to add it up right here. That's how you need to know what S mean, the P mean, the D mean, and the F mean. And that's for electron configuration. Now moving on to topic 5, which is the Lewis dot structure. You need to know the atomic configuration in order to do the electron. You need to know the electron configuration in order to do the structure for that, because they're connected. Right here. That's how you'll know how many electrons in the thing that you'll need to add or subtract from each one to get what you need. And here's a diagram of it right here. Now in the middle, P is the lowest one, and that's because the atomic number is 6. Once you add all the atomic numbers on the outside of the middle one together, you will add all of them together, you will subtract it by the smallest one, which is P, which is 6. After you do that, that's when you're basically gonna get 20. Then you add up the dots, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and therefore to get 18. Once you subtract that, you subtract 2. Then you subtract 2 minus 2. And that's how you will be able to solve for the like structure. And that's just one of the structures. And right here it just tell you that it's a domain. Now that domain is specifically saying how the geotraffic lining looks like, basically how the shape is, how long it is, where it's pointing at, everything. Now, on each shot will be an electron, dominant electron, that you would basically put dots around it to name the atoms. That's what name the electron that's with the atom. And that's how you'll get it right there. 2 domains, 2 atoms. So it's probably going to be this 1, 2, 1, 2, basically. And then right here will show you using the element form. So that moves it on to topic number 6, which is the VSEPR theory. Now the VSEPR theory basically predicts the shape of the electron pair repulsion, and its shape depends on whether it's a lone bar or a loaning pair or a bonding pair, and the geographic of it, like this, where it's basically at. It's also a prediction. It helps with predicting too. That's why it matters. All these matters because they're either essential to life or they help you read technology as far like an MRI. Like the quantum number, it helps you read the technology of an MRI, and it reads the energy based off the transfusion of a atom. Then you got the waves that will help you see what skin cells are in damage. That's for waves and waves and frequency. And then you got electron, just help you see clear images like tumor, bloods, help with that. Now with the theory, it's going to help you predict what's going on, what do the person need, basically, and what is not working for what is failing, what is not failing. And it all goes with the atoms that is bonding, the electrons that's with the atoms that make the atom work and everything. And so the VSEPR stands for the valence shell electron repletion theory. That's what it stands for. Now there are other theories. There are other theories that we'll go over, but the main one is this theory because you're mainly going to use that to predict what is ordered. Now to help predict a form and obey the order of octet. Octet has many different rules and regulations that you will have to follow. Like if the theory is more than, if the domain has, like the theory or the bond has more than 8, can't do it. If it has less than 8, you can't do it. If it's odd, you can't do it. If it's fewer, you can't do it. Like you have to follow the rules. So you have to know the bonds between the atoms in order to do it. Now here are three elements with different bonds, shapes, and angles that are a part of the VSEPR theory. Oh, and like I said, right here, the VSEPR has different bonds and different theories too. These are the different theories. These are their domains, and they're arrowed in certain ways, so you'll see. Now the bottom one is the highest one, so it's right here to show you how many domains it has. 6, 5, and 4 domains, and these are the different names for them. Same with the rest of these. And one of them, if it doesn't have 2 bonds, and then it's no bond, like basically right here. And these are for the not geographic. And these are for, these are how you know. These are just for bonding. Because the theory is mainly about bonding, where there's 2 electric groups center atoms in two groups such as oxygen. Now the linear electron is one group, and then the shape is what bonds the bond of the angle. So there is a difference between those two right there. And that's mainly what you will need for those. You just mainly have to know what type of bond it is, shape it is for that one. Now, the second topic will be about bonds, more bonding, ionic bonding, and chemical. The chemical with that is a system named as a compound shown to compulsion, and then the icon is a metal and non-metal. It's a metal and non-metal, adding it to make up compounds prefix showing numbers of atoms. So here are 3 examples for each one. And these are all on the periodic table. These, like, literally, they're all on the periodic table. They're just separated because it's 2 bonds coming together. So they're separated by the bonds, and the number of each bond, like how many, the number of each bond and what it means. And that's how you'll separate them. So, right here. Di is 2. And it's only those because they're coming together. Now the separate ones, they'll each have different bonds. So that is important to remember too. And those are the 7 conceptions, the 7 concepts of chemistry and why they're important, especially to the nursing field and to us.